This micromodule will focus on how to perform and understand clash detection. A clash occurs when components that make up a build asset are not spatially coordinated and conflict. In a BIM process, these clashes can be easily spotted during the design phase of a project ahead of work starting on site. As with the previous micromodule, in order to demonstrate this, we will use Autodesk's Navisworks. To conduct a clash detection within Navisworks, you must first select the clash detector tool. We will do this within Navisworks, but before we do this, let's have a look at what this tool will look like and some of the priorities that must be given in order to ensure that it runs correctly. Here we have an image of what the clash detection will look like. If we focus on number 1 and 2, the first thing that we need to do is click on Add a Test. Once this is done, we can then select between selection A and selection B what we would like to clash, what models, or we could expand the model and choose floors or objects within the actual model. Let's focus on number 3. This is where you choose what to clash. So for example, you can choose to clash surfaces. The default clash option is usually surfaces. Surfaces clashes only the surface or 3D face of the selected objects. You can choose lines. This geometry type clashes items with center lines, usually used in conjunction with pipes, or alternatively you can choose points. This geometry type allows you to clash points, usually when clashing point cloud data from a laser scan. Let's look at number 4, the settings, the type of clash that you would select. This is very important, and there are usually 3 types of clashes. A hard clash. This is a clash in which the geometry of selection A intersects that of selection B by a distance of more than a set tolerance. As we can see in here, it's a hard clash between 2 objects. Or a clearance clash. This is a clash in which the geometry of selection A may or not intersect that of selection B, comes within a distance of less than set tolerance. So this is where we would go that pipe A must be at a certain distance from pipe B, and if not, then this is a clash. And the third and final one is a duplicate clash. This is a clash in which the geometry of selection A is the same as that of selection B, located within a distance of between 0 and set tolerance. So this is when the same geometry obtains the same space, and this is known as a duplicate clash. We must then now select a tolerance. The tolerance controls the severity of the clashes reported and the ability to filter out negligible clashes, which can be assumed to be worked around inside. Tolerance is used for hard clash, clearance clash, and duplicate clash types. Any clash found that is within this tolerance will be reported, whereas clashes outside of the tolerance will be ignored. So for hard clashes, a clash with a severity of between 0 and the tolerance value will be ignored, whereas for clearance clash, a clash with a severity of more than a tolerance value will be ignored as it's further away than the distance required. Similarly, a duplicate clash with a severity of more than the tolerance value will be ignored, as this is likely to be a separate yet identical piece of geometry. Tolerance is a distance that we allow our objects to intersect or be apart from each other before they are notified of a potential clash. Once this is all done, the final thing is number 5, and that's to run the test. Let's now have a look at Autodesk Navisworks and how this clash is set up going through this process. Here in the Home tab, we have our clash detective. Let's click on this and run through the process just discussed. We select the clash detective. Here, the first thing that we need to do is add a test. And we need to add a test and name it based on what we intend to clash. In this instance, let's clash our architectural first floor against our MEP first floor. Once this is done, we go to selection A and selection B. And here I'll choose architectural first floor and MEPP first floor. Next thing is to choose surfaces, lines, or points. The default option is always surfaces, and this is the clash that I intend to do today. In the settings, we choose hard conservative, clearance, or duplicates. In this instance, I'm looking for two objects that hard clash into each other, and I'm going to look for a hard clash in this instance. Also, in the tolerance, I've decided that 50 mil is the allowed tolerance. So what I'm saying is that any object between the architectural first floor and the MEP floor can penetrate each other by 50 mil, but any more than that, then that is to be notified as a clash. And now I'm going to run the test. What we can see is that we have 143 clashes. With a clash now executed, we need to understand what the clashes actually mean. Clashes are organised based on severity. For hard clashes, the severity of a clash depends on the intersection of the two items intersecting. Hard clashes are recorded as a negative distance. The more negative the distance, the more severe the clash. Hard clash severity depends on whether the conservative or normal intersection method has been applied. If normal, the greatest penetration between a pair of triangles is measured. If conservative, the greatest penetration space around one item into the space around another is measured. This is a typical display of what you would see when viewing a clash after the clash detector was run. Let's take a look at this in more detail. Here we can see number 1. Number 1 is where a list of all the clashes are found in the model. So as we can see in here, this is where we can see all the different clashes that correspond to the number of clashes which has been found. 2 is the display setting toolbar, which provides a number of options on how you would like to view the clashes. This gives you a selection of different ways to view the clashes within the model. 3. This is where the clash is viewed and explored. By using the options within the display setting tab, you can focus directly on the clash. And 4, as we can see here, will tell you exactly what two objects are being clashed within the model. This will give a breakdown of the two elements and can be used in conjunction with the selection tree. Let's now take a look at this in greater detail in Autodesk Navisworks. So let's have a look at the clash results in more detail. I've created a second clash between the structural node level and the MEP node level. This is where I selected the node level in MEP and the node level in the structural model, but this time I set it to a clearance, keeping the same tolerance. This resulted in a total of 8 different clashes. So if I go to my results tab, I can see that I can have different display settings to view this clash. We can see that item 1 clashing is red and item 2 clashing is green. We can also dim other, which means that we can see this clash in the context of the whole building. Alternatively, we can go highlight all clashes and we can see all 8 clashes highlighted within the context of the whole building. We can also see over here that the issue is that there is a minus 0.681 millimeters of a clash outside our tolerance between item A and item B. We can see down in here further that item 1 corresponds to MEP node level galvanized takeoff base, and item 2 corresponds to the structural model W36 by 150 here. We look at another clash, for example. We go to potentially clash 6. We can see that there's an issue here. We can see that our MEP PVC pipe is clashing with the structural model W2476, which is the name of our beam. And we can see that's clashing by 9 mil. So we know that this pipe needs to be raised by 59 mil in order to satisfy our tolerance. If we look at clash 7, we can see here, if we zoom in, that while there is a distance between the MEP standard, which is our pipe here, and the structural W136 by 31, which is our beam, we can see that it's only 38 mil and it needs to be moved out a further 12 mil. We can trace these back also to the selection tree in here. And here we can see when we select our structural item, corresponds to that in the selection tree, same with the MEP within the MEP model here. If we want to check this, we can use some of our refute tools. Select item A, select item B, and go shortest distance. Here we can see the 38 mil, which corresponds with what was found here in the distance. If we rerun this test, for example, we will now see that we have no new clashes, but these 8 clashes now become 8 active clashes, meaning that they are still in the clash detective and there has been no answer. It will be up to the clash detection manager to go through each one and give them a reviewed, approved, or resolved status. In a number of instances, there will be clashes within the model that aren't clashes, such as potentially a wall touching a floor. It'll be also up to the clash detection manager to create rules in order to ignore these during batches of clashes. This is outside the scope of this lesson plan, but it's worth noting that this is how the clash detection is set up, as well as how it's refined to ensure only true clashes are reflected. The final part in regards to clash detection is understanding and generating reports. You can produce various clash detection reports. So for example, reports can be used to communicate coordination issues to design teams that don't have access to Navisworks. Reports can also be exported as digital requests for information. The image below provides an illustration of a digital RFI generated from the report section in the Clash Detective. Let's now return to Autodesk Navisworks and see how this function is executed and how to understand these RFIs once exported from the program. If we access the Report tab here, and while keeping on the structural node level versus MEP node level clash, we have a number of options of how we'd like to view these clashes. For example, it's asking, well, what status of clash would you like to export? So we can see in here that the clashes that are relevant to us are the clashes that are active. Last, the report format, so HTML, HTML tabular, or viewpoints. In this case, I'll choose viewpoints. I'll now write a report, and this will come up in my viewpoints tab over here, which we originally used in the viewpoint earlier in the lessons. And here we can see clash 1, 2, 3, 4, 5, and we can use a combination of review tools as well as information back in here in the results between assigning or adding a comment. Clashes can also be grouped together, which is outside the scope of this lesson, but that will enable clashes that are similar to be put into a grouping in order to make it easier for anyone that is viewing the model. Another option is to go to the report, and this time to change it to HTML tabular, and then write report. This will export the clashes out into a setting that can be then forwarded on to relevant design and construction team members. This is what this would look like in the HTML tabular format. Here we can see the image of the clash, the name, the item1 and the item2. This is based on the contents here, and by having these ticked, this will come up when we export into the HTML tabular. Autodesk Navisworks, as well as other design review packages, have a number of other capabilities that can be performed outside of clash detection, walkthroughs and markups. These include 4D simulations. They can also provide 5D costing capabilities. In order to further understand more on clash detection, a video has been provided here to assist with self-guided learning. This video demonstrates the lessons learned in clash detection. With the basic understandings of the fundamentals now gained of clash detection, we can now see how this can be used out on site or during clash detection or site review meetings. As we can see here, the federated model can be reviewed by the construction team during clash review meetings, and potential issues can be solved before they happen on site. The federated model with all the information could be loaded into the common data environment and downloaded for consumption by the project team. This means, as in this instance, as we can see through site BIM stations, that the team can interact with the model, compute clash detections, walkthroughs, interrogate information, and can use the federated model to assist in better installation on site. To recap on the lesson, design review software can help to provide in-depth constructability reviews, as we've seen through markups, can reduce risk through clash detection, can help to better understand site and logistic constraints, can be used to visualize construction sequences and access on-site and off-site progress across the project lifetimes, can automate quick takeoffs to enable costing for a given design to be produced faster, as well as communicating information visually and therefore reducing the potential for error through language barriers.